What we're going to be working on today is two sections, so section 1.1 and 1.2. I'm probably going to cut this into two videos, but 1.1 is going to be the short one where it's talking about what in general we're doing. There's this idea of conic sections. So what they are is if you take two cones and you stack them on top of each other. So you got cone one, and then you got cone two, cone one, cone two. And depending upon how you slice a plane through them, you get different shapes. So if you've got this nice flat, just whoosh, even flat slice through the two cones, you only touch one of them, so you just get a circle. If you kind of tilt it a little bit, so it's like a little slanty, um, but still cut in and out of the cone, then you get an ellipse. So it's like a little wonky circle. If you cut it even slantier to the point that it is like it's not actually exiting the cone, like one end of the plane is staying inside of the cone, you get this parabola shape. This is the one that we're probably most familiar with. We did circles when we did the unit circle stuff. Ellipse is a little wonky. Hyperbola is the only one that really takes into account that idea that there's another cone on top, because we got the cone below, cone on top. The hyperbola, the plane touches both of them and does the same thing that the parabola is doing, and it creates two opposing parabolas like on top of each other. Now, for this chapter, kind of like our trig identities chapter, we've got this big page of information. It's got all the formulas. You don't need to memorize any of these formulas. You just need to be able to use this sheet. But I want to talk as well about this idea of a general form. These are the standard form of the conic sections, but a lot of times we get them in general form. And general form is sort of the worst. You can't easily tell which one is which. Like this one is a little bit easier to spot, but this one you really can't tell just by looking at it. You have to do some calculations. And you use that discriminant thing from inside the quadratic formula, b squared minus 4ac. That's that thing under the square root when you do the quadratic formula. You check those values, and if that's spinning out a certain number, it'll tell you which conic section you're going to get. So let's try it out. So I've got this example. I want to determine which conic section it is. So I've got my general form over here. Let me get out of the way. There we go. Can I not be like that, please? There we go. All right. So we've got ax plus bxy and then cy squared. So we only really care about the x squared term, the xy term, and the y squared term. All this other stuff, d, e, and f, it's useless. Don't use it. It's not going to help you determine which conic section it is. It's just more kind of shaping the conic section. But we don't really care about it when we try to determine which one it is. So we have our A. Oop, I need a pen, please. Our A in this thing is 1. Our B is also 1. I'm just grabbing these coefficients that are on the x squared, the xy, and the y squared term. And the thing with y squared is -1. So we put that into b squared, so 1 squared minus 4 times our A, which is 1, times our C, which is -1. So I'm just putting it into this formula right here, b squared minus 4ac. And I want to see what that gets. So I end up with 1 squared, that's 1. And then this is plus 4. So it's 1 plus 4, that is 5. 5 is bigger than 0 because you're always going to check these against 0. It's either going to be 0 or be smaller than 0 or bigger than 0. Our thing was greater than 0. So it was this piece. Oh, sorry, wrong mouse. This piece right here. Since it is bigger than 0, this thing is a hyperbola. That's just what the paper tells us. So that's what we're going to do. Hyperbola. Okay. That's it. We've determined it's a hyperbola. That's all we're doing for this part. In the next one, we've got an x squared term. That's our A. So that's 2. We don't have an xy term. We can't see it. If you can't see it, At all, it's 0. If there's no number in front, the coefficient is 1. And our c value is 2. So we do 0 squared minus 4 times our a, which is 2, times our c, which is also 2. We get 4 times 4, which is minus from 0, -8. -8 is less than 0. Okay, so who's that going to be? If it is less than 0, it is an ellipse. Ooh, cool. Ooh, but wait, ellipse has a little special caveat. A circle is a very special ellipse. So first you check this. So you got ellipse, but it's like, ooh, is it the best ellipse? The nice perfect circle one? Is A and C the same? Yeah. Our A value and C value are the same. So this thing is a circle. It's a special ellipse. Since A and C were the same value, they were both 2. Finally, we got this last one. This last one's a little silly looking. We look for A, the x squared term. I don't see one, so it's 0. We look for B, the what term? B is the xy term. There isn't one. And then C is our last thing, y squared term, which is 1. So we do 0 squared minus 4 times 0 times 1, and we get 0 minus 0, which equals 0. Huh? Well, if it actually equals 0, then it is a parabola. So since this thing equals 0, our shape right here is a parabola. And that's how we identify our conic section.